I've been staring at this product rule for an hour. This is a climate change major. Why do we need to study calculus?
I know, right? We should be out in the field, not solving for V prime. When are we actually going to use a derivative to stop a flood? It's just a theory.
If you're wondering when theory becomes action, you might want to watch this.
Every year, the story is the same. The recent flash flood in Cebu showed us the danger isn't just the water's height, it's the terrifying speed at which the height changes. As future disaster managers, we need the mathematical tool that measures this acceleration: calculus.
To understand the threat, we must ask, how fast is the flood depth changing right now? That instantaneous rate is measured by the derivative. If h of t is the flood height over time, derivative of h over the derivative of t is the speed of the rising water.
The total flood height is a product of a high rainfall and a poor drainage canal. When both are changing, we use product rule. The rate of change is accelerated by the acceleration of rain, U prime, multiplied by the existing poor drainage, V, plus the heavy rain, U, multiplied by the rate of drainage failure, V prime. If B prime is high, say if a drainage system suddenly collapses, the flood depth accelerates catastrophically.
The flood will eventually recede, but the damage has been done. It leaves a tons of amount of uncollected waste, turning a disaster zone into an environmental hazard. The calculus of change doesn't stop the tides. Our challenge is to shift from stopping the water to cleaning up the mess.
And this is where the action starts. We are BULSU environmental science students, and this cleanup drive is our project. And we are using calculus again. The rate of waste removal, and waste removal is a product of volunteers U and their efficiency V.
Look, if more people are coming, our rate of change just accelerated. Calculus says that if both my organizing U prime and the field research efficiency V prime increases, the trash disappear faster. So basically, calculus says move faster or the trash wins.
From the critical acceleration of a Cebu flood to the positive acceleration of a BULSU cleanup, the derivative product rule is the language of action. It shows us that environmental outcomes are the product of two or more changing factors.
Wow! The product rule isn't just about numbers. It's about compounding threats and teamwork.
Exactly. We aren't just calculating rate, we're calculating resilience.
That's why you stand up, let's go now, let's go and apply it.
Rising tides teach us how fast problems can grow.
But cleanup drives reminds us that change can flow in the opposite direction.
Calculus help us both see two things.
The problem and the progress.
Through the language of rates and change.
We are the Eco Warriors.